Hi everyone, and welcome to this revision video on solving harder trig equations. So recently in the lesson we've looked at solving simple trig equations, and we're going to just continue that process now by looking at when I'm solving sort of a multiple of x. So instead of something like cos of x, instead of something like cos of x equaling to a half, I now have 3x, or so cos of 3x, or I might have sine squared x equals a quarter, or I might have tan of 3x plus 1 equaling 0.5, or something of the sort. So I don't just have x anymore, I now have some function of x for which I'm trying to solve. So I'm just going to follow the steps, same as we did in the previous lesson. And we're going to start out by saying, well, I need to always check whether it's degrees or radians. So I can change my calculator and adjust the period if needed. So the period is given to me here, and it is for x. And when I look at question 1, which says solve cos of 3x, well, in this case, I want to solve 3x, so I'm going to just do a little trick. And I'm going to turn this, I'm going to multiply that by 3, so I'll still get 0. And then x times 3 will give me my 3x. And when I multiply 360, I'm going to get 1080 degrees. And that's going to help me to find all of the solutions for 3x in the correct period. And then at the end, I will simplify. So that's step 1 done. We've changed our calculator to degrees because my period is also in degrees. Let me just do that on my calculator as well. Okay, we're ready for step 2, which is find the principal value. So for my PV, I'm going to say that, actually, hang on a moment. Hang on. For what I'm going to do is step 2. In this case, because I have 3x, I'm going to make a little substitution, and I'm going to say let theta equal 3x. And I do this before I find my principal value. So this means I now have cos of theta equaling to -1/2, and now I'm ready to find my principal value. So I say theta is equal to cos to the -1 of -1/2, and I go and work that out. Shift cos to the -1, and that gives me 120 degrees. That is my principal value. My next step is always I need to find my second solution. And for cos, that is 360 subtract 120. And if you recall, I showed you this little trick in class where we said cos is positive in the bottom right quadrant. Cos is positive, all positive, sine positive, tan positive. So my second solution for, I always get my first solution, which I call my PV, and then to find my second solution for cos, I need to do 360 minus. We discussed this, so hopefully this will be familiar to you. So my second solution for theta will be 360 degrees. Take away 120, which gives me 240. I then go and list all my solutions that I've found so far, which is 120 and 240. Now remember, I always need to compare it to I need to compare it to my period there. So I'm going to have to find all of the solutions between 0 and 1080. So because cos repeats, every 360. All I'm going to do is add on 360 degrees to each of these solutions. So that's going to give me 360 plus 120 is 480. 240 plus 360 is 600. 480 plus 360 is 840. And 600 plus 360 is 960. And anything beyond this, because I just keep on adding 360, anything beyond this will be greater than 1080. So I found all my solutions. I've completed step 3. And step 4 is to simplify. And this is then going back thinking, okay, what does that mean? Well, remember, I made this little substitution here. I made that substitution and I said let theta is 3x. So in actual fact, 3x is equal to 120, 240, 480, 600, 840, and 960. And now I can do my final step, which is simplifying, so dividing by 3, so I get 40, 80, 160, 200, that's going to give me 280, and that's going to give me 320. And now I know when I go back and check, originally I wanted to find all the solutions between 0 and 360, and I have done that for this example, cos 3x equals negative a half. Okay. Moving on to the second example, solve sine squared equals 1/4 in the interval 0 to 360. Okay, so my initial bit, I check I'm in degrees, don't need to change anything on my calculator. I also do not have here, I don't have to change this because I just have x here. I don't have 2x or x plus 30, for example. So I'm going to start by just simplifying sine squared. Okay, because I want just sine x. I have to get rid of the sine squared before I can solve this. So that means I'm taking the square root for both sides. And remember, the square root gives you both a positive and a negative solution. So that's 1/4. And therefore I get sine x equals the positive answer, which is a half, or sine x equals the negative answer, which is negative a half. So the square root of 1/4 is a half, but I get plus minus a half. Okay, so in this example, I actually have 2 equations which I need to solve. And for both of them, I want to find my answers between 0 and 360. So again, I go, step 2 is to find my principal value, which is the value that my calculator gives me. So x is equal to sine to the minus 1 of 1/2 will be the principal value for equation A. Just going to label them separately, and feel free to pause the video and have a go at this yourself. That when I find inverse sine of a half, I get 30 degrees. My next step is always to find my second solution. Okay, and I know that my second solution is, sorry, I just see I've made a mistake here. It's sine minus. Oh no, sorry, sine plus, but it's going to be 180 degrees minus my PV. Like for cos, it was 360 minus my PV, and for tan, it will be 180 plus my PV. Okay, that's where sine is positive in the second quadrant. So my second solution will be 180 degrees minus 30. And I did explain, hopefully you remember in the lesson, where this comes from. We looked at the graph and we could relate why one answer is 30 and the other is 150. Okay, so those are the 2 solutions for equation A. I also need to do the same for equation B. The principal value is going to be inverse sine of negative a half. So I'm going to do inverse sine of negative 0.5, which gives me negative 30 degrees. And then my second solution, I say, is going to be 180 degrees subtract negative 30, which becomes 210. Okay, so if I list this out, then for equation A, I get x equal to 30 degrees and 150 degrees. Remember, always compare in the end. Have you found all the solutions in the given period? I have, so I'm happy with that. Because if I add 360 to either of these two values, it will go over 360. Now I check for equation B, my two solutions, negative 30 and 210 degrees. And when I compare this, I notice, well, okay, negative 30 falls outside of the period. And I use this example in lesson where imagine you standing on a wall, you're tied to your friend by some big rope and you jump off to the grass the other side. This is a really random example. Then your friend will be pulled up onto the wall. Really random example, but what I try to illustrate with that is if one solution, if you jump over, your friend's going to come up. So if negative 30 falls outside, then there's going to be a solution that comes back into the interval. And to find that solution, I need to add on 360. So 360 to negative 30 gives me 330. So in total, I have 210 and 330 and 30 and 150. So I always go and summarize that in the end to make sure it is easy to see where my final answer is. Okay. Right. That is example number 2. Let's look at example 3. Solve sine of 2x plus 30 equals 1 over root 2 in the interval 0 to 360. So again, I'm going to start my step 1, or my initial thoughts are I need to check degrees. Okay, my calculator is in degrees, I've made sure. Step 2, or the next bit of this part, is to look at this. I now don't have x anymore. I've got 2x plus 30. So I need to adjust that to 2x, which gives me 720 and 0. But then I also need to add 30 to it. Okay, so 2x plus 30. So I add 30 to 720. I get 750 there. And I add 30 to 0, so I get this. Okay, so I need to find all the solutions in the period 30 to 750. Okay, so again, I'm going to make a little substitution before I find my PV. Let theta equals 2x plus 30. So I get that sine of theta is equal to 1 over root 2. I then know I need to find my PV. So theta equals sine to the minus 1 of 1 over root 2. I'm going to work that out. Again, pause the video if you'd like to have a go. That gives me 45 degrees. My second solution is what I find next. And for sine, my second solution will be 180 minus 45 degrees, which gives me 135. My next step is to go and write out all my solutions and to compare it with the period to make sure I found everything. So at the moment I've got theta equaling 45 and 135. But when I compare it, I know I need to find all of the solutions up to 750. So what I'm going to do is just add 360 to each of these solutions. which means I'll find the next two, because the sine graph repeats every 360 degrees. And that's going to give me 495. Then I do the same to this. I add 360, until eventually the answer that I get will be greater than 750. So that 405 plus 360 already gives me an answer greater, 765. So I know I am done. I've found all my answers in the correct period from 30 to 750. Then finally, I need to go back and recall that I made a substitution here. The answer is actually not theta equal to all of those values, but 2x plus 30 is equal to 45, 135, 405, and 495. And so now I simplify that, I subtract 30, and I go and divide by 2, just like I would solve any other equation. 45 subtract 30 gives me 15 divided by 2, so I know that x is equal to 7.5. Then I do 135 minus 30 divided by 2, and I get 52. 52.5 degrees. 405 subtract 30, divide by 2, 187.5. 495 subtract 30, divide by 2, gives me 232.5. And I compare with the original period. Yep, I found everything between 0 and 360. Okay, hope that's useful. Moving on, let's look at a slightly harder one. We spoke about having an equation where it's not just in terms of one trig ratio. So here I have sine and I have cosine. And in this instance, if you recall, I'm going to turn into tan of 2x. But before I do that, I also notice, okay, I've got 2x there, but my period is just for x. So I'm going to times that by 2 to get 2x, times 2 pi by 2 to get 4 pi, and times negative pi by 2 to get negative 2 pi. So I want all my solutions between negative 2 pi and 4 pi. And the other tip I gave you is just to turn this into decimals in the instance that I don't have nice exact values, so that you can, it's easy for you to see when you found all the solution. That's negative 6.28. And 4 pi is equal to 12.566. And that's just handy to know when you found all your solutions. Okay, so now let's have a look at this. I have sine of 2x equaling to 2 cos 2x. So I'm going to divide by cos 2x, and I will get tan of 2x equaling to 2. Okay, I'm next going to find my principal value. Ooh, hang on a minute. Before I do that, I make a little substitution. Let theta equal to 2x. So tan of theta equals 2. And now I find my principal value. Theta is equal to tan to the minus 1 of 2. I should have said in the beginning, I'm also in radians. You probably noticed that. So straight away go and change your calculator's units to radians. So tan to the minus 1 of 2 gives me 1.107. Question will specify how many decimal places or how many significant figures. Let's just say in this instance I want 2 decimal places. That's what I'm going to use. 1.107 there. I will round in a minute. No, let's just round now. Actually, I've rounded that incorrectly. That's 1.11. Okay, I need to find my second solution. And for tan, it is going to be, if we go back to this little handy diagram here, it's going to be 180 plus my PV. But remember, I'm not in degrees now, I'm in radians, so it's pi plus my PV to get my second tan solution. So I'm going to say pi plus 1.11, which gives me 4.25 to 2 decimal places. Might be useful actually not to yet round to 2 decimal places and just write 3 or 4 digits after the point, but and then you round in the final step. But to keep things simple, I'm just going to stick to this strategy. So I go and list out what I have, all my solutions, 1.11, 4.25. I also know then it's easy to see, oh, I need to find everything up to 12.56 and down to negative 6.28. Now recall that tan repeats itself every 180 degrees or pi radians, which means we're not adding 360 or taking away 360, we're adding and subtracting 180, and because we're working in radians, we're adding and subtracting pi. So I'm going to add pi there, and I'll just first find all my answers up to 12.566, and then I'll work backwards and subtract. So I've got 4.25 plus pi, which gives me 7.39. I add on pi again, 10.53. And if I add on pi again, well, I know pi is 3.14, so that's going to take me over 12.566. So now I need to subtract pi. So it's going to be 1.11 subtract pi, which will give me, and I'm just going to write my answer here, negative 2.03. And then I subtract pi again, and I get negative 5.17. Now, if I subtract pi again, it's going to take me over the lower boundary of the period. So I found all of my solutions. There are 6. 1, 2, 3, 4, 5, 6. So I'm going to list them out in order of size. And I must remember, there's always lots to remember when I solve a hard trig equation. I made a substitution. So I'm going to say 2x is equal to, I like to list them in order of size, negative 5.17, negative 2.03, then 1.11, then 4.25, and then 7.39, and then 10.53. And then my final step is to go and divide by 2. So let's do that. Negative 5.17 divided by 2 is negative 2.59. Next one, hang on, negative 2.03 is negative 1.02 rounded. And that's 0.56. That is 2.13. 7.39 divided by 2 is 3.70. So that's 5.27. 5.27. And there are all my solutions. to 3SF. So just one thing I want to remind you of, I did round here. I rounded in this row. Well, I rounded here really. It's probably best to add on a few more digits each time, a few more digits, then go and divide everything by 2, and then you round. That will be more accurate, and that's what you should do in the exam. Okay, I've got 2 more questions I'd like to work through. So let's move on to one that looks like this. Sine squared, 5 sine squared plus 3 sine x minus 2 equals 0. So going through my process, I notice I am in degrees. Change my calculator to degrees. I also notice, okay, I've got a combination of sine squared, sine, and a constant. And this is actually in the form of a quadratic, right? So it helps to make a little substitution. It helps to say let y equal sine of x. Because if I let y equal sine x, then this equation will turn into 5y squared. Sine squared is sine squared x is y squared, plus 3y minus 2 equals 0. I've turned it into a quadratic so that I can find my solutions. So I need to factorize this. I want to find solutions for y. And that's going to be 5y and y, and that will have to be 1. I want plus 3. So when I multiply these two, I want plus 5. And my other factor of 2 is minus 2. So I solve that, and I get that y is equal to 2/5, or y is equal to -1. So I haven't started at all finding my PV. I'm first just trying to find the solutions to sine x. So remember, I made a substitution. So I can now say, therefore, sine x equals 2/5, or sine x equals -1. And then I go back to my process. So let's have a look at this. I want to find my principal value. This is equation A, and this is equation B. I've got 2 of them to solve. Principal value x is equal to sine to the -1 of 2/5, which gives me 23.6 degrees to 1 decimal place. My second solution, it's for sine 180 degrees minus 23.6, which gives me 156.4 degrees. I compare it to my period. Very nice, 0 to 360. I only had the 1x, and this was x and x. It wasn't 2x, so I didn't have to make any adjustments. So I know already that 2 of my solutions will be 23.6 and 156.4. That's for equation A. If I now look at equation B, and I'm just going to move this over here, then what's nice is I have a value that's really easy to work out. So anytime I have -1, or I have 0, or I have 1, it's really a lot quicker just to think about the graph. The graph of sine x looks like this, and I have -1 there and +1 there, which means in this instance there's only one solution to that, and that's 270 degrees. 270. So straight away I know the answer to sine x equals -1 is 270. However, if you don't like that method and you want to stick to the steps that we did, you just go and find the PV. So x equals sine to the -1 of 1, which is going to give you 90. Sorry, I didn't add in -1 there. That's why that's wrong. That gives me minus 90. And I notice that that falls, sorry, I'm first going to find my second solution. So that says for sine it's 180 minus 90, which becomes 180 plus 90, which is 270. So x is equal to minus 90 and 270. I notice that this one falls outside. So I add 360, but when I add 360, I will also get 270. Okay, which means in the end, that gives me another 270, which is exactly what I already had here, which is why I say if you have -1 or 0 or 1, it's much easier just to sketch the graph. It just saves you that bit of time. So my three solutions are 23.6, 156.4, and 270. Those are my solutions there. Okay, on to the last example. 2 cos squared x plus 9 sin x equals 3 sin squared x in the interval -180 and 180. I've made this quite easy for you. I've only had one question with radians. Maybe we should change this, just change things up a bit. Let's do between -pi and pi radians. Okay, so hopefully you notice straight away I've got cos squared, sine, and sine squared. I can't solve it unless it is, well, in this case, I can't solve it unless I change it to 1 trig ratio. So this is my clue here. There's nothing I can replace sine x with. I have sine squared, and I know I can therefore also, given I have cos squared, I can rewrite cos squared as 1 minus sine squared x. So I'm going to do that, sub that in there. 1 minus sine squared x plus 9 sine x equals 3 sine squared x. Okay, go and expand those brackets. 2 minus 2 sine squared x plus 9 sine x equals 3 sine squared x. Rearrange it. So I will get, if I move everything to one side, 5 sine squared x minus 9 sine x minus 2 equals 0. I just moved everything to the right, and then I swapped it over again. Factorize or make a substitution. If I make a little substitution here, let y equals sine x, then I get 5y squared minus 9y minus 2 equals 0. Pause the video each time if you need to, so you can have a go at this yourself. It's really good because I'm going through it quite fast at the moment. Okay, so that's got to be minus 2 to give me minus 10, plus 1 to give me my minus 9 in the middle term as the middle term. So that means y is equal to -1/5, or y is equal to 2. And then I must remember that I need to unsub. I need to go and change it back to sine x. So this means that sine x equals -1/5, or sine x equals 2. Now I'm going to start with this one because it's nice and easy, simple to see, hopefully, if you know your graphs well. You know that the maximum and minimum of sine x is 1 and -1. So given that 2 is up here, there is no solution. There's no point of intersection. So this will have no solution. So all I need to do is solve where sine x is equal to -1/5. And given that I've drawn the graph here now, I might as well go and add this in. We know that my two solutions will be there and there. So I go and find my PV. There's nothing to change other than putting my calculator into radians. But it's x. I don't have to find a multiple of x. So make sure your calculator is in radians. And then x is equal to sine to the minus 1 of negative a fifth. Sine to the minus 1 of negative a fifth, and that gives me negative 0.201. Dot, dot, dot. Useful to think about this in terms of decimals. That's minus 3.141, and that's positive 3.141. I want to find all my solutions in between there. So my second solution for sine is going to be pi minus 180 degrees minus, so pi minus negative 0.201, which gives me, shift pi minus, gives me 3.342. Now I notice, well, let's first write this down. I've got negative 0.201 and 3.343 when I round this. I notice when I compare it to the decimals, top one falls out, bottom one is all good. So if the top one falls out, you're jumping over the fence and the rope is pulling someone else up onto the fence. So this one falls out. I can't add on 2 pi. I need to take away 2 pi. Remember, sine repeats every 2 pi. And so I'm going to have negative 0.201. And that answer minus 3.343 minus 2 pi gives me negative 2.940. And so finally I just write that in order, negative 2.94 and negative 2.01, 3SF throughout. Okay, I hope that was useful. Send me a message if you have any specific questions about this, and I will be happy to help you. Keep on practicing. This is hard, but if you get the steps right, you will be absolutely fine.